Hello everyone, welcome back to the classes of electrical circuits ECE 111 where we solve or make circuits or make the circuit solving easier. So today we are here to discuss about a topic which is known as star to delta and delta to star conversion, which is very much essential for determining equivalent resistance. So for example, suppose if you want to determine the equivalent resistance between the terminal A and B here in this circuit, then as per our previous knowledge, what we normally do is we try to identify the connections which are in series or parallel, and then accordingly we go for determining their series combination or parallel combination, and then moving into step by step formulation or simplifying the circuit. Finally we determine the equivalent resistance. But in this case, as we can see here in this shape, this 4.5 and 7.5 resistors are not in series or parallel combination. Similarly on the other hand side also, so it is difficult to identify if the circuit is of this form. So in order to get the solution out of this circuit and to determine the equivalent resistance, we have to take help of star to delta and delta to star conversions. So to start with, first let us see what is a star and what is a delta connection. So this connection, as we can see here, this triangular connection consisting of resistance Ra, Rb and Rc is known as a delta connection. Okay, as we know, the delta is given by the shape, so this is a delta connection. Next, the other one is known as star connection, that is constituting of resistances R1, R2 and R3. So how to get the derivation or how to get the conversion? That means we are going to determine R1 with respect to or as a function of Ra, Rb and Rc. This is conversion of delta to star, and other way around we are going to determine Ra with respect to a function of R1, R2 and R3. This is called conversion of star to delta. So how we are going to define this or how we are going to determine this? So to do that, there is a derivation which is available in any book, so we can go through and where we can determine the corresponding formula. Okay, so in order to see what are the corresponding formulas, so let us first consider delta to star conversion. So in this case, as we can see here, the black ink is the delta and the red ink represents the term which we are going to convert. That means this delta function we are going to convert into a star form. So in simple words, we are going to convert this circuit into this. So in order to find the relation, so which is given as the conversion or the value of R1 is obtained by multiplication of RB/RC divided by Ra plus Rb plus Rc. So if we see closely, we can determine a relation like as we can see here, this is your R1. So the value of R1 is equals to multiplication of Rb and Rc. So what are Rb and Rc? Those are adjacent branches. So Rb and Rc divided by the total, divided by addition of total, that is your Ra plus Rb plus Rc. So similarly, if you want to write down for R2, so for R2 it will be adjacent are Rc and Ra. So Rc Ra divided by total, that is your Rc plus Rb plus Rc. Similarly, if you write for R3, so it will be, this is our R3, so adjacent are Rb and Ra, so Ra Rb divided by total Ra plus Rb plus Rc. So if you follow this rule, then there is no requirement of remembering anything. So now let us move into conversion from star to delta. So now we are converting from star to delta, means from R1, R2 to R3 we are moving into Ra, Rb and Rc. So in this case the formula says it will be Ra equals to R2 plus R3 plus R2 R3 divided by R1. So this is our Ra So how we can relate this here as, so the corresponding remaining branches R2 are R2 and R3 in this triangle, and so R2 plus R3 plus again R2 into R3 divided by the remaining is our R1. So like this, if we write down for RB, then it will be, we have R3 and R1, these are our branches, then plus multiplication of them divided by remaining is R2. Similarly, if we go for RC, it will be R1 plus R2 plus again multiplication of them divided by the remaining is R3. So using this logic, we can write down the formula without even remembering. So for example, suppose if we are considering conversion of this circuit into a, suppose this is 1.5, so we are converting, suppose this star into a delta. So what will be the corresponding values? So without remembering anything, you can directly write it down as, suppose this is your x, so x will be equals to 2 plus 3 plus 2 into 3 divided by 1.5. Similarly, if this is your y, so y equals to 3 plus 1.5 plus 3 into 1.5 divided by the remaining is 2. Then suppose this is our z, so z, what will be z? Z will be equals to 2 plus 1.5 plus 2 into 1.5 divided by the remaining, which is 3. So this is as simple as that. So instead of remembering any formula, so suppose if you are trying to remember everything by remembering the formulas, so for remembering the formulas, you have to, first thing is you have to remember formula, and the second thing you have to remember the circuit also, because by some mistake if you are putting this RC as RB, then if you are remembering this formula, then your calculation will get wrong. So instead of moving into this loop, so what we can do, we can simply consider this logic and then determine the corresponding formula. Similarly, for delta to star conversion, we can use the formula like the adjacent branches, that is your R2 into R, for determining any value of, suppose R1, R2, R3. So what are the adjacent? Adjacents are your RC and RB. So for R1, RC and RB, multiplication divided by total resistances, addition of total resistances. So using this, so now let us consider how to solve this numerical. So as you can see here, this numerical can, in this numerical we have a delta connection here, similarly a delta connection here. Since both are having same value, so if we solve one, the remaining one can be solved automatically, or we are getting the value automatically. So this will be the conversion, right? If we convert the star into delta, so now what are these values? Sorry, we have to convert the delta into a star. So what are these values? So suppose I am putting this as first this one as x, this one as z, this one as y. So what will be x? So our x will be, as we know, 4.5 into 7.5, right, divided by total resistance, that is 4.5 plus 7.5 plus 3. So if we do calculate, it will come out to be around 2.25. Next, what will be y? Y will be this resistance and this resistance, so 7.5 into 3 divided by 4.5 plus 7.5 plus 3 equals to, it will come out to be around 1.5 ohm. Then similarly z equals to these two resistances, so those are 4.5 into 3 divided by 4.5 plus 7.5 plus 3 equals to 0.9 ohm. So whenever we are solving this type of numerical, we have to redraw the circuit again after conversion. So now our circuit will look like this. If we see it properly, it will look like this, right? This will be your AB, Now this x we are getting as 2.25, right? Similarly on the other end also we are going to get 2.25. Then this z resistance we are getting as 0.9 ohm, so other way around also it will be 0.9 ohm. Then the remaining is 1.5 ohm. On the other side also it will be 1.5 ohm, because the values are same, so the calculation will be same, so we are not repeating the calculations again. Then this will be 4 ohm and the remaining is 3 ohm. Now it is simple conversion where we can see this 3 are in series, these 3 are in series, so our circuit will be like this. So after calculating the series connections, so we will be getting it as 5.8, that means 2.25 plus 4 plus 0.9 will be 5.8, and then remaining on the below end it will be 6 ohm, and these are already 2.25 ohm, and this is also 2.25 ohm. Now next circuit, as we already know, these two are in parallel, so it will be having 3 resistance in series. Finally 2.25, 2.25, and the middle one comes out to be 2.95 ohm, right? So if you are having any doubt, so for parallel resistance what we do it like this, right? If you remember, so this is 2.95. now combining all of them means in series we just add them, so 2.25 plus 2.95 plus 2.25 will come out to be 7.45, which is our answer. Okay, so I guess you have understood how to convert star to delta or delta to star conversions. So I will just consider another short numerical for your understanding. So we have converted delta to star, right? So similarly, let's see what will happen if we convert star to delta. So in that case, suppose I am considering this circuit. So there are resistors connected in this manner. So suppose, and let us give them generic name R1, R2, R3, R4, R5, R6. So suppose you were asked to determine the resistance, equivalent resistance between these 2 points. Suppose this is A, this is B, this is C. So suppose you are asked to determine between AB or AC, it can be anything. So let us consider we are determining across AC. So as here also we can see there are no combinations like series or parallel, everything seems to be mixed up. So in this case also we have to convert from star to delta or delta to star. So if you see here closely, the middle connection provides a star connection, right? So if we convert this into a delta, so it will be like this, right? I am using different color for understanding. So this star will convert it into this form, in this format. So if I check what I will be getting after conversion, so it will be like this. If you see it closely, so it will be looking like this, right? Now we are determining between A and C. So now again what we can see here, again these two resistors are in parallel, these two resistors are in parallel. So what we can do, we can convert them into parallel formats. Similarly, these two resistors are in parallel format. So after converting into parallel format, I will be getting this, right? So combining these two, suppose I am naming them as R3, this was our R1, this was our R6, This is suppose Rx, this is suppose Ry, this is suppose Rz. So this is nothing but R1x, that is your equivalent resistance. This is your R3y and this is your Rxz. Then we are determining with respect to ANC, so these two are in series, so Rix, then combination of R6z 3y, right? Then again they are in parallel, so we'll get the equivalent resistance R1x6z3y, right? So this is how we are going to solve the numerical. So what are the values of Rx, y and z? So what the value of Rx is equals to R2 plus R4 plus R2 into R4 divided by, this is R5, right? Similarly Ry will be R2 plus R5 plus R2 R5 divided by R4, right? Then xy is done, next is z, so Rz is R4 plus R5 plus R4 R5 divided by R2. Okay, so this is as simple as that. So now put the values, determine the equation, you will get the answer. Okay, so this is all about your conversion of star to delta and delta to star connection. I hope you have understood it well, and now try to solve the numericals, and I definitely feel that you will be finding it easier. Thank you for joining.